really? Okay, so let's start today. Yeah, nice to meet you all
Yeah.
here again to our next free course from Smart World Education, Artificial Intelligence, and this is part one, the birth of the logic era. And part two, I will spoiler a little bit for you. Part two is about hands-off. So in 2 weeks, we will show tools and all of that, how they work, and I will show you online how to work with that. You can follow that on your side also, or you can see how this is working, how AI programs and progress work. But let first, before we start to talk about AI, we have to clarify a lot of things because the internet and what you read on Instagram or so many experts tell you about AI is a little bit messed up. Yeah, it's very necessary that we have to talk about some things in AI which you have to understand, which we have to understand, and yeah, maybe reshaping our idea about what AI really is. So, um, let's talk about what this course will not do. Um, we have no hype, we have no AGI myths, and we have no fear marketing. And this is exactly what happens outside there. They hype it, then they tell you you missed something. And if you think you missed something, you will invest in courses and whatever you invest. And after a couple of time, the project, the guy who has told you in that is gone for good. That always happens every day. We call it scam or however. And this is why we do not talk about a hype and know about an AGI myth, that means general AI, and we do not make fear marketing. We want you from understanding coming into the situation that you are doing. Yeah, that is a changing thing. Yeah. If you understand what we had here in this part, you will more likely have it easier to get onboarded with the tools we show you and can make your own mindset about all that stuff. So AI did not start with ChatGPT. When people talk about artificial intelligence today, many think it suddenly appeared a few years ago. So, like a thunderstorm, it was there and then it fall from heaven or something like that. But the truth is, AI has much longer history. And AI research began in the 1950s. At that time, scientists believed that if we could describe human thinking as logic and rules, we could simply transfer that into machines. In other words, a machine is following rules and yeah, and the idea is why not describing what we want from the machine? And so we started with machine learning. Every computer from the very beginning of the 1980s is nothing more than you have a computer language and then you describe what the computer is doing. So a machine today is nothing more than a computer inside a mechanical system, and so we can describe what we want and it is delivering. The original goal was ambitious to make machines think like humans, and early researchers were extremely optimistic. Some believed human level intelligence could be achieved within a few decades. So you see, in 1950s, 1960s, and even beginning of the 1970s, the human race was thinking that sometimes there will be a machine which has a brain like the human and can act sovereign. And from that optimism led, we saw a lot of development in AI. I would say that optimism turned out to be premature. What followed were cycles of hype and disappointment. You can expect. You see, also we have a lot of hype now and also disappointments. And today, these cycles we call AI winters. Yeah, because in the winter is cold, everyone is frozen and something like that. So when a cycle of AI hype is over and the business is going to normal business back and has understood that there is nothing more than some intelligent talk, we fell back into an AI winter. Yeah. The problem wasn't the idea of intelligence, but the limitations of computing power, data, and mathematical models. So think about that concepts of AI and computing power has early started in the 1950s, and the mathematical breakthrough in computer technology was in the early and late 1970s. Most of the computers we see today working and running are based on concepts and coding ideas and mathematical ideas starting in 1978. So what we see is the outcome, what we today see, is a long, long process until we could put mathematics into computers. And the problem was what we changed was not the intelligence itself, it was the scale. That means we have more data, more compute, better statistical methods, and this leads to an upscale on computer power and make it happen that now millions of people can tell ChatGPT what they want in the same second without the system is crashing. Yeah. Think about you have a calculator. Yeah, and this is the smallest item of a computer today, you know. So now think your calculator can run thousands processes in a second simultaneously from thousands of users. So your calculator is used by thousands of students at the same time without having two machines. Yeah, but it could fulfill everything about that and can calculate in thousand times at the same time. Yeah, we call it simultaneously. This is what changed. More data, more compute, and better statistical methods. That means we had a lot of problems when we come to big data. Big data was a couple of years in the mid 90s it started, and it was on the highest point in the 2000s. We collect everything about everyone, about every time what happens. So now we have billions of datas, and we hadn't got the computer power to use that datas or feed a machine with them because it was too slow. So think about when million people now type in a prompt and it is in a second the machine is answering. If it was 20 years ago, the machine would have for this a need time from more than 5 years. So you can imagine how fast our computers have become. Yeah. So that's the magic about. It's not the logic behind an artificial intelligence system. It was described in former times also. It was the necessary of computer power to serve millions of people with that idea that they can use an AI and ask something and get an answer without having to wait 5 years. Modern systems like ChatGPT don't think. Yeah, many people are impressed by these machines, and then they say, "Oh, they must think." And sometimes you see, I'm thinking. That's nothing. They model patterns in language with extraordinary precision, and this is a point we have to discuss about. Model patterns in language. Every one of us has his own way to talk. Yeah, so some people are very good in English, British English, American English. We talk about African English or whatever, every accent. So it happens in all languages on the world. What we have today is that machines like ChatGPT, they can recognize the patterns in language and then they can translate it into computer code. And from that point, they answer you in computer code, but the machine is transforming it back into a language we understand. It's all about computer power. And it's very precise. So when you talk about AI today, we are not witnessing the birth of intelligence. We are witnessing the industrialization of logic. That means there is no intelligence, that means the machine is not going to, oh, I have an idea and I want to tell you my idea. What do you think about? It's the other way around. We tell the machine something and it is looking up with his um, ability to force the internet, to brute force some documents or something like that. It is going to look up if our purpose is right or wrong, or can we do this? How can we build this purpose? What have we to do? Which are the next steps? And then it is delivering to you what's going on. And that's in a scale, it's industrialization of logic. And understanding that difference is crucial for regulation, for business decisions, and for society as a whole. And that's a very, very, very strong point. We need to build and train these machines in differency because you come from a different cultural background than me, for example. So things for me are normal, for you are unusual. So on the other hand, things you do and how easy you do things, maybe for me a little bit concerning because I have to think about it, about security and something like that. And during I'm thinking, you're doing the job and you're finished. Yeah. So we have a different background, and that's what machines behave today. ChatGPT, Gemini, or Grok, or whatever you use from an AI is learning really fast. What's your background? What's the sound of your voice? And how is the speech you talk? Yeah, when you write something, what is the kind of style? So it is mirroring you and says, hey, I'm your buddy. I understand you. I can talk in the same way you do. And that makes you believe that the machine has some kind of spirit or something like that. But in reality, it's just code which is working behind and say, hey, learn the pronunciation, the world of this person who is typing into your chat window. So it learns permanently from your inputs. And it is not going like that, like a psychologist or psychologist and say, psychologist, and you open ChatGPT and it is asking you, how was your day? What have your wife done? It could be if you code it, but the action comes from you. Yeah, the first sentence is there. What's up today? What can I do for you? So the action is on your side and the output comes from the other side. If you talk, you can talk over the microphone with ChatGPT. Yeah. So if you talk to ChatGPT, you can have a dialogue. It feels near humankind. Yeah, because you discuss the answer is coming. It feels really, really real. But don't forget, you're just working with a computer code which was meant to be to assist you. So, has anyone questions at the moment? Is there someone who wants to know something, who has question or can't follow? I'm too fast, too slow, whatever. Okay. Um, After this session, you have also the time to ask questions. Okay? You can go there and ask questions, everything fine. So, um, let's talk about the first wave of rule-based systems. The first artificial intelligence wave was rule-based systems. And that means the very first generation of AI was not about learning, it was about rules. These systems were built on explicit logic. Um, these systems um, have been be able to translate human knowledge into formal instructions. Yeah, so they understand what you are telling, and then from your sentence, they pick up keywords and put it into a instruction. So they can simply say, okay, you saying the weather is fine, we should go to the sea. The only thing the computer is recognizing is go to the sea. If the weather is fine, or you say the weather is fine or something like that, these are fill words. And the computer learned to ignore fill word. So when you talk to ChatGPT and you type in your whole life, it is only looking for, is this relative to the context he want to? He wants to go to the sea. Does it make sense to take care about the first part when he says the weather is fine? Yeah. So the machine is short in the way what you are talking about. But if it is not answering in the same way, you will likely see this is a machine and you are not free to talk to the machine. I'll give you a good example. In the beginning, when we started, and I had a lot of sessions with Angelica, she always tried to find the right words to talk to the machine. That's happened because when you are older and you had a little bit experience with computer, you always think if I do not describe it in the right way, messy is coming up. So what happens here is you can talk in the way you are talking. You just have to define and refine what you exactly want. So if you are just saying, oh, the weather is fine, I'm going to the sea, you didn't define which sea. Is it the sea next to your home? Do you want to drive by car? So the machine is giving you an answer. What the machine is thinking is the most common thing she can answer to that input. Then you say, "Oh, I didn't mean that you go to the Baltic Sea. We want to go to the Eastern Sea or whatever." Yeah. So then you have to refine that thing, and we can work faster if we make our mind up and think about what we want to tell the machine in the beginning. That will really fasten up the whole show. Yeah. So when we talk about the early systems, rule-based systems do not adapt. That's what ChatGPT is, what I said. It is adapting your kind. They don't learn from experience. That was the very beginning. They don't handle ambiguity well. And every new exception requires another rule. As complexity grows, the system becomes fragile, not intelligence, just complicated. So the first AI wave taught us an important lesson. You can encode logic, but you cannot encode the world. And this is what we call experience. Humans have experience in the world, machines do not have. Yeah. That realization paved the way for the next wave of AI systems that don't rely on handwritten rules, but on data and probabilities. That means that they started to shift over in a way that we do not have no rules to follow rules, but more access data. And from that data, they have probabilities which is right or which is wrong without you have to tell. So that what we call context machine learning. Yeah. A good example when it all started. This moment looked like a breakthrough. In 2011, a computer program called Watson defeated the best human champions on Jeopardy. Um, that was Watson was created by IBM, and it is something of the grandfather of ChatGPT. It was framed as a historic victory of artificial intelligence over human knowledge. Yeah, Jeopardy, who didn't know, is a it's a game show where you have to answer questions. Well, we will take a look. And in a way, Watson was incredibly powerful within a very narrow frame. Well-structured language, clearly defined questions, massive curated data sets. That means it was trained on data sets which have been um, curated by humans before. Yeah. So, and fixed rules of interaction. But something important happened after the show. When Watson was moved into the real world, and that was medicine. For example, ChatGPT has now a part like a doctor. Yeah, you can ask them also about medicine and something like that. Um, Watson was starting that also. And when it comes to medicine, business, decision support, it started to struggle. When you hear today about an AI that it is telling you nonsense, what we call hallucination, Watson has done this in 2011 also. Not because the AI was the artificial intelligence, not because the artificial intelligence was weak, but because reality is messy. And that's exactly what it is. Yeah, real life has incomplete data, shifting meanings, contradictions, context that changes faster than models. Watson didn't fail because it wasn't smart enough. It failed because the world isn't a game show. And that's exactly what it is. This was a turning point for AI research. It showed us that intelligence in controlled environments does not automatically translate into intelligence in open systems, and that insight directly shaped the next generation of AI systems designed not to know the right answer, but to operate under uncertainty. Yeah, so we go back and say, okay, you do not know exactly what the meaning is. Now you have to learn from the context of the meaning. That's exactly what it was becoming, you know? And this is exactly what we see today when we talk about all that stuff. So Watson is a preview of ChatGPT, yeah, with less computer power, but it could understand human language, yeah, and it could act to the human language. And this is a very different thing from what we have seen before. We have we had a lot of things what we showed and use case before, but Watson from IBM is the prototype of that what becomes later ChatGPT or other systems. So what I want to show you next is um, we will see if it is working here now. I will show you a video about Watson. So my computer today is very slow, so have a little time. Um, and yeah, let's see what happens. The browser is opening, they're very slow today. Yeah, but it is not the problem. When you think about ChatGPT or Gemini, and you think about the differences, it is always about how good these machines can understand context. So, while the color green, it doesn't say which kind of green light green is in. And that's from the picture like the color of green you like.
So is somebody just
Ah, here we are. It seems that the connection was lost. Can you hear me? Can you all hear me?
winning or
Mm.
Now we can all hear you, yes. But
Yes, here we
whatever
are
is
back
said
again.
before you,
Okay. So okay, the end of Watson. I was talking about that Watson was the first ChatGPT. Yeah, this was the prototype. And Watson
wait,
was also the first system which was showing us that you can't trust the machine if you do not have the right input. So from Watson, the maker of ChatGPT learned that it's necessary not to know all the knowledge, but to combine the knowledge it has with the context the user got. So ChatGPT is learning from you. You see a color green. So it is saying, okay, he likes green, but he do not knows which kind of green you like. So a light green, a dark green, a middle green. So it looks in the context of all your chats and pictures you use. And if you put a like on a picture and says that's great and that's great, it tries different greens and then you say, wow, that's it. It it measures and learns that this is your color. So Watson couldn't do that. So when it comes to medical affairs, and that was the point when they stopped the Watson project from IBM, it was in universities, it was in clinicals, and people used that, doctor used that, but then it made different output and it was falsified. It has the knowledge, but it couldn't address the knowledge to the context. And then it happens that it was working wrong in the medical care. So they had to stop the project because they had to confess that Watson is not be able to come into a professional area. And you have seen 10 years later, ChatGPT is there and was going a different way, but the basics are the same. ChatGPT can understand our language. That's exactly what it is. Yeah. So I think
yeah,
Gaston has a question.
I think now it's clear. The problem was the language. Now GPT can understand it, and I like it.
Yeah, it can understand your language and it
Jörg,
can understand. Yeah.
Explain it to me
No.
when there was the technical.
Sorry, what? Can you repeat your question?
problem.
yeah, and he was, asking if they are, if they have something, together, if they have the same builder or whatever, creator. So now everything
No,
is clear.
no, no. The first thing was IBM. The company IBM was creating Watson, and
Yeah,
Can I
yeah.
ChatGPT is based on
can
Google.
Yes, please.
okay? Can I ask another somehow so that we go first after clearing everything?
Yeah, yeah, you can.
You you see the for us who have no background technology,
Hmm.
it is
Yeah,
not easy to understand those things related to code. You see, code, when we understand the word coding,
yeah,
sometimes we are afraid because people who these things they say these are so much that they related to data, mathematics, and if you are explaining all those things, we who have no that background, we don't understand anything. And
yeah. I know.
if something you mentioned, those there is communication. What does it mean? The communication of those kind of code.
Okay. Let me explain it in very simple terms.
things so that
Our,
we start GPT talking
yeah,
with me as a real person.
yeah,
I would
um,
like to understand what is happening
yeah,
out,
yeah, yeah. So
because
think
this
about,
GPT can react and more than a
think,
human being.
yeah, think on something. Everything we do as human beings is a logical sense. So if something happen, then we have an output. Yeah. So, for example, you go to your neighbor and you have a mind that you want to talk to him. So the output is you
Yeah, yeah.
go to the door, knock on the door, and sit in. So if we do
Uh-huh.
something, then something is happening. When we started
Okay.
with computer code, the idea was to tell the computer if something is there, then you have to do that, or you have to do that if another case is coming in. So if, then, or, then, do this is computer language. Yeah. When the people build the first computer, they understand to make the computer understand basic language, for example. If the counter is going 2 times, you have to stop where you are. If you do that, you
Okay.
have to do that. So the different thing is now we have a lot of knowledge, and
Uh-huh.
ChatGPT is based on the same rules if then, but there is another thing. When you talk to the
Uh-huh.
machine, it is going to translate it into an understanding machine language. That means when you say something should be done, it is the same. If then, that's rules. Yeah. So ChatGPT is not seeing what you're saying. It's just understand if then I should do this. Or you ask for look up something. Then it is looking what is the meaning of your words? What is the meaning of the picture you upload? For that case, ChatGPT was training 5 years from 2016 until 2021 the whole knowledge of the world into the machine and was saying, hey, ChatGPT, a tree looks like that. Hey, ChatGPT, a cat looks like that. Hey, if you see, because a machine can't see a cat, it sees a lot of dots. Yeah. It sees
Yeah.
101. Yeah. It sees like you look on your screen. And if you go with a glass on your screen, you see dots. Yeah. Colored dots,
Okay.
simple dots. And that is a whole picture. So the machine has to learn when a dot is on position 1 and 2 and 3, that is a line. If it is going down, it's a line which is going down. So that we had to train the machine always and always, and we used for that a different technology which I present later. But the machine is dumb. She could not go somewhere and says, "Wow, that is a house." She can only recognize a house because we have showed them and trained them thousands and millions of pictures of houses. And now she understands that a rooftop can be flat or it can be broken. But that was years full of work from scientists to put that into the machine because it needs a
Yeah, yeah,
lot
yeah,
of
yeah.
computing power, right? So there's nothing like that. You come to the world, you as a baby, you run around and stumble, and then your father is coming around and saying, hey, this is that, this is that, this is that. You visualize it and you can feel it, you can taste it, you can touch it. Yeah, that's different experience for you. Our brain can connect our feelings, our moods, and what we see and what we understand and build a picture
I got
of
it.
ourselves. Yeah.
Thank, thank you. I got it.
Oh,
It
great.
is the language. Just to
Yeah.
understand the interconnection.
Yeah.
They
That is the interconnection. Yeah, right.
have we taught them to spread using those codes or those uh, the way they have taught them, they can interconnect.
Right, they can interconnect. That's exactly what it is. Today we have a lot of databases. One is, for example, psychology of humans. Then it can read that, and then it can understand the context in that, and then it can say, okay, if you ask what is a human being, then it can say, okay, a human being is someone who is acting on his independently. He's walking on the earth. We have humans on earth, that is not something the computer recognized by itself. It has learned that it is so. So if you ask something about which food is good for me, it had learned it from thousands of books before. It was never coming on the idea and
Yeah, yeah,
taste a poisoned champion or something like that. It was never, no, never going that way. Yeah. So it learned from our knowledge. And exactly this is what the magic is. It is reflecting our knowledge. It is not creating new knowledge. It is just combining that.
yeah. It combines those information and it see in code and directly it respond.
Yeah. And it can combine things. I give you an example. If you think about, I want to use that car and then I want to drive to the castle, and from the castle, I want to do the next step going to the sea. That's 3 points you have in your mind. You think a whole day about it, which is the best way, where you can go, where is it cheap, what can I do, how will the weather be, and something like that. A machine today
Mhm.
does it in a break of a second. All these
Mm.
tasks at once. So you can imagine that this power of the machine is not reinventing something, but it can combine our knowledge much faster than we can do. And then it can say, surprise, surprise, this is my output. But humans maybe come to the same output, need more time. So when we study something, we need years. Today, with these machines, we can get the same output in minutes because they are so
Yeah,
fast in combining.
yeah,
Yeah,
yeah.
that's the difference. Okay,
I,
so let's
thank
go on. Yeah, you're welcome. After Watson, this is what an AI winter looks
very
like.
smart.
Yeah, fine.
It is very smart. You are very smart.
Thank you. Thank you. Thank you. So, yeah, let's go on. Um, when Watson was finished, the hope of the people of AI was gone for good. No investor was going to make money in that, yeah? The promises were bold, but they were not fulfilled. Systems were expensive, maintenance was complex, results were brittle outside controlled environments, and as expectations collapsed, something else followed. Funding stopped. That's exactly what happens, yeah? Everything they were thinking of, they had the idea it will become a really good thing, was stopped. Governments pulled back, yeah, because the governments were very likely about AI. They pushed it into the medicine and the healthcare centers, yeah, but then it failed, so they all get wet feet and run away. So companies shut down their labs. That was also, there was no investigation in that whole thing because they said, okay, this is a big mistake. And entire research programs disappeared almost overnight. And with that, public trust collapsed. And that was the point. The publicity was not believing in AI anymore. So that's what happened when the AI winter came. Yeah, AI was no longer seen as the future. It was seen as an overpromised technology that failed to deliver. And this wasn't because AI was useless. It was because expectations were misaligned with reality. What people wanted was intelligence. What they got was automation with limits. And every AI winter teaches the same lesson. Technology does not fail first. narratives fail first. When we promise more than a system can structurally deliver, we don't accelerate the progress, we delay it. To understand this is really, and that's why understanding what AI is just as important as understanding what AI is not. And this is in our times now also. When we talk about ChatGPT and everything, we have to talk what could it be and what could it be not. Because many people think about a general AI is coming and something like that. And it's not happening because it's not possible from logic. Yeah. But then they are disappointed, and then they have an illusion, and here it was the same. They had an illusion, yeah, on big waves only begins after the illusion collapse. That's what it was and what it is in the future. So after Watson, there was a long time nothing. But then the rise of the neural network started. This where the real shift begins. And this was when something changed. After rule-based systems failed to scale, artificial intelligence took a different path. Instead of telling machines what to do, we started letting them learn from data. Neural networks were inspired by the human brain, not as a biological copy, but as a mathematical abstraction. So think about, we know a little bit about how our brain is working and how we can remember things. Yeah, you know about your consciousness, your subconsciousness, and something like that. And mathematical abstraction tries to catch this into rules. So say if you use a hammer and you hammer your thumb instead of the nail, you learn from the feelings, and then your brain is building a path where it can remember the pain. So they started to think if we build neural networks, we can go a similar way. Something is going wrong, the machine gets an information that is wrong and will now recognize for the entire rest of the lifetime that this is the wrong path. But as you know, things can change, and maybe you use a hammer, I use a hammer, and you put it on your thumb, and I put it on my thumb. I have more pain than you because you are used to be having pain when you work. So our brain is separating that, yeah, different from people to people. A machine can't separate from machine to machine. They are not individuals. Every machine, every ChatGPT is the same, exactly the same as the ChatGPT on your computer. There is no difference in coding. It is not changing his code from himself. When we have a big bad experience, we can reboot us and make out of a bad experience a good feeling. A machine can't do. It's impossible. An artificial neuron doesn't think. It calculates. It takes inputs, applies weights, sums them up, and passes the results through a function. What changed everything was repetition. With enough data and enough compute power, these networks began to recognize patterns that were impossible to describe with handwritten rules. So the more informations we gave the system and the more power we had, it could compare different situations faster and can see a pattern in that. So this is exactly how a machine is learning. It is learning from comparing and find a pattern. So when I say, for example, we have a row number 1, 3, 5, 7, which would be likely the next number? You will say 9 because you have seen 1 to 3 is 2, and from 3 to 5 is also 2, from 5 to 7 is also 2. The machine is going that same way with millions of data and can then recognize this pattern. This is and we many people say this is intelligent. This is not intelligent. It is understanding a logic thing. because it is built on logic. Yeah, it is a statistical approximation at scale, in other words. Neural networks don't know why something is true. They learn what usually works, and that's powerful. It allowed machines to see images, recognize speech, translate language, detect patterns in complex systems. But it also introduced a new trade-off. As performance increased, explainability decreased. We gained adaptability but lost transparency. That was the problem. So we want to know how a machine solves a problem and what have been the steps to come to this solution. Because if the machine is presenting you a solution, that doesn't mean that we can recreate it. So that was a big problem. The more we got, the less we explained and make it transparent. And that tension between accuracy and understanding defines modern AI. So if you work with ChatGPT or something like that, you can watch the steps she's doing. You just type in something you want to see, give me the results of soccer and make a forecast which party will win the race. So then you put only one sentence in and say, let me follow what you are doing step by step. And then ChatGPT writes, I look up the internet. I create a table. I'm going to calculate on the table which party has the most points. And you can see step by step until it comes to his forecast and say, okay, the party A will win the race. And you can follow it. If you do not do, you just get the suggestion of the machine, party A will win, but you can't follow that. And this was also a big thing in law. In law, they said we have to make clear and the machines to tell us what they are doing, because otherwise we can't create laws around where some mistake is identifiable. That was what happens. Today, and many people say ChatGPT is a neural network. That's wrong. If you see the papers and the studies and the coding of ChatGPT, you will likely understand that this is not a neural network. It is a totally new point how a machine is storing his knowledge. It's very different from that. As you see on the slide, we talk about RNN and CNN. What you have heard about now was um, RNN, neural networks, recurrent neural networks, that's what it is. And CNNs are convolutional neural networks. That means the difference is on RNN, we try to rebuild the way our mind and our brain is working. On convolutional networks, we try to rebuild how our eyes memorize. So that's the thing. When you play memory, your eyes recognize which place was the card. Yeah, and then it saves the information into your mind map. And that was also a way with CNN try to understand um, how we can build pictures in a convenient way into the machine. So translating a picture to a machine code, which the machine is understanding. And if you show the picture, it will say, oh, that's a bird. Yeah, they had their times when they were really next to face. At least this where many narratives get simplified, sometimes too much. CNNs and RNNs didn't fail at all. They solved specific problem extremely well. CNNs revolutionized image recognition. That's what I said. RNNs made sequential data like speech and time series usable. but they had structural limits. CNNs are spatially local. They see patterns but struggle with global relationships. RNNs process information step by step that makes them slow, hard to scale, and fragile over long contexts. That's exactly what it is. The more data you give into these machines, the harder they have to try to find the answer, the harder they have to build the map where they store the informations and can um, react to a context. In short, they work, but they don't scale to complex, high context systems. When we come to ChatGPT is a so-called transformer model, which was invented by Google by an accident. In 2017, Google announced a system, a translator for speech, and it works very, very well, the Google Translator. This is built on a transformer model. The transformer changes the words into computer code, then it has an attention on the context and changes it back into the different language. Google missed that point that someone will come around and use that and say, hey, if a machine understands what we are saying and can switch it into a different language, why the machine is not switching our context into process? And that's what the founder of ChatGPT has been realized, and he was the lucky guy who built a team around him who made a software around the transformer called ChatGPT. Because the transformer software itself was open source, so there was no copyright. And now, with millions of dollars, Gemini, the pendant from Google to ChatGPT, was going into the market and wasted a lot of money to take up with ChatGPT. Yeah, because they missed the point when the time was there. Transformers, instead of processing data sequentially, they look at everything at once. Attention mechanisms allow models to relate distant elements, maintain long-range context, and scale efficiently across massive data sets. This is not about being smarter. What that means, an transformer model. Think about you have to do a homework, and you should order a row of numbers and words. So think about dogs. So there are different kind of dogs. So you have a list with 1,000 name of dogs, and then you have to order them into groups. So transformers can organize different groups at the same time and can build a context between these groups. Yeah. So they are really, really fast in that. So, and they do not need that much space that a CNN or RNN uses on computer space. And it is easier for them to make points. Yeah, so you say something to ChatGPT, it is looking up in its matrix, where are the points and where is the context and where is the next point, which is going that context. And then they can build the words and everything around very, very fast. And this is the most impact on that thing, that transformers find a way to store their informations where they can find what in a way which is much efficiency than the old systems have been. So that's why we are so fast with answers. CNNs and RNNs will never be giving you an answer so fast than a transformer could do. When we talk about, for example, you see, some people of you have created a picture with ChatGPT, yeah? So, and CNN model is going like that. It sees something, then it makes a map, and then it creates a picture of that what it has seen, and then it tries to connect this picture to informations you have given the machine. Yeah, for example, it sees a picture of a flower, it copies the flower, the structure of the flower into a system, and then it is looking if you have given the machine some information about that structure and what the structure could be. When we talk about transformer models and you create a bit picture with ChatGPT, we talk about stable diffusion. This is not a transformer replacement. It's a generative process that often use transformer-based components. Yeah, so you say, I want to have a picture with a flower, then the transformer is building a flower out of millions of pictures of flowers and combine these pictures new to a new flower picture. Then you can say, I want to have a sunflower. It presents you a sunflower, but in a different way, all the pictures it has been trained on. So every picture you got is an original. Even if you say, wow, I know Mickey Mouse there. Yeah, there must be copyright. No, because the Mickey Mouse is not in the same picture as you have seen on TV or in the movies. The Mickey Mouse is a totally different area. It looks like the Mickey Mouse, but it is built out of a sudden accident from points coming together, creating this picture from the knowledge of all pictures of Mickey Mouse and, for example, the town where it is now. So when people talk about copyright, they have to understand that the way how we create pictures today with a computer is not copyright. It is combined from thousands of dots from millions of pictures to a new picture. Even if the Mickey Mouse looks like the Mickey Mouse, it was not built by just copy and paste the Mickey Mouse. And that's important to know. So we see here matrix operations, attention, and probabilistic generation. And this is all optimized for scale, efficiency, and context handling. That means today we are in a lucky situation. We can create a build in seconds where we otherwise with old computers need years to do something similar. And that's the magic what people are frightened because they say in seconds you can create a picture of your neighbor. Yeah, but when real, it's not your. It looks like, but it's not copy and paste, and this makes headaches for the people who run copyrights. Yeah, because it was not created as a copy, even if it is the same picture and it's you on the picture. Yeah, and this is a really thing. It's hard to understand, even for lawyers. Yeah, but this is the reality. And when we talk about AI, we are living in the times of generative AI. This is the rise of generative AI. We can do text, we can do images, we can videos. And AI is not only telling us, okay, make a summary from this document and then tell me what you think about, and then make a research in the internet to this topic and find other texts and combine them and give me a whole report. That is what I say is the basic function of a transformer model, a large language model. Yeah, this is the basic function of AI today. But as you can see, you can create Word documents, you can do pictures, you can do videos with the AI. You can human-like outputs creating and creative content. Yeah, outputs that look creative, that sounds expressive, that feel intentional. And that's important because perception matters. But let's be precise. Generative AI is not creative in a human sense. It doesn't imagine, it doesn't intend, it doesn't understand meaning. What it does is something very specific. It learns the probability structure of existing data and generates new combinations, what I said, that statistically fit the patterns we recognize as human-like. Yeah? It is looking for pattern and says, okay, this must be a pattern which is look like a human. That's why the outputs feel familiar. Not because the system is human, but because it mirrors human data at scale. That means it can mirroring our data which we have given the machine to reflect us in a human way and make us believe as an illusion that this machine has some kind of life. Yeah, because it is not going to have one by one. It is going scale and do millions of times at different homes the same. Yeah, everyone has ChatGPT. Millions of people have ChatGPT. So it is working for everyone individual in the same way by mirroring what this person is doing and recognize what kind of person is the person in front of the computer. And this is incredibly powerful. Yeah, it's very incredibly powerful. It lowers barriers. Anyone can write, anyone can design, anyone can create prototypes out of ideas. But it also blurs boundaries. The machines can produce content that looks human. We must be clear about where authorship ends and where responsibility begins. Generative AI doesn't replace creativity, it amplifies it. And like every amplifier, it makes both signal and noise louder. The real challenge isn't generation. The real challenge in that is judgment. So if you can create everything, is that something which is necessary? Is it something which is fun? Is it something who can harm? And here is the way. If millions of people use AI and they do it in a way that they harm other people, you can't judge them at all. You can't run for every door and say, you have used your AI for that reason. So what they do is they want to track the chats. Yeah, because if you know you are tracked in a chat and you can be traced and you can be charged but what you are writing, you will think twice what you are writing, in which way you will write it, yeah, and will make up your mind if they can charge you or not. But if you stay in a mass of millions of people, you can write whatever you want. You can hire a killer or something like that. Yeah. This is not the idea of AI. The idea of AI is that you get free knowledge of everything. So we are in a risk between censorship and privacy. So for me, my personal opinion is we need more privacy because I will tell you what, our world didn't fail before AI. We had the same problems. Yeah, we have crime, we have child abuse, we have whatever you can mess up with a human being. Yeah, everything you can imagine, we had before AI. And the people found their way. So if people know they are watched in an AI or they had a censorship AI, what do you think they do? Really, they find another way to do the same without using their AI, without becoming on radar. And this is exactly what the misunderstanding is when it comes to say we have to put in ethical concerns or something like that. We have to do it and we have to manage the system. We have to tell the machine it can't tell the people that and it can't tell the people that. No, the machine can tell the people everything. It's on us to make understand that humans are not willed to be, I would say, in a right way acting by nature. Yeah, you can see it. You can see it, little childs. Yeah, they run into a shop when they are 6, 7 years old and steal something from the shop. Then someone is telling them that's not okay. The parents coming and they had a lot of terror, and then the child is deciding the terror was not uh, the way I should go to the shop and steal something. Okay, so we learn from that basics. But what we do is with the machine is saying, hey, you guy, you run that ChatGPT, you run that Grok. So we have to censorship you because people misuse it. For the, I will say 80% of all people use AI for help, for understanding, for a good way. Now 20% of these people use that in a wrong way, and I don't understand why 80% of people who doing in a right way have to suffer from these 20%. And this is what we call ethic. When we talk about ethic and ethical rules, we have to understand that the majority of the people, you can't charge for something they never will do. So we have to find a way how we can track and filter these people without breaking privacy. Because if you use for a chat about child abuse, you can use keywords or something like that to force all that thing. But that doesn't mean that an investigator has to know how many times you have been divorced. Right? That's exactly where we have to separate. And that's the way how we have to code ethical shields into AI. That's exactly how we can separate privacy from verdict. But if we do not do, everyone is under verdict, everyone is not becoming that benefit from ChatGPT or others because they learn who you are, they learn what you are, they learn your favorites, they learn what you make angry, they learn everything from you and can support you in a way only your best friend can do. And if you work with your machine and you're on your workplace and you use this machine in the same way you talk to the machine private, you will see this machine is a full assist to you. If you are ill and sick, the machine can do what you can do because it learned everything from you and it is building the next steps in the way and in the kind how you work. But if we manage that we can't use it in that way, we throw away all benefits of this revolutionary idea of ChatGPT. Then we can say it's a better Google. Then we lose all the benefits. And when we come to ethical, the question is ethical interpretation. Yes, we have some ethical standards, but look, our world is in war, and ethical rules only a phrase to those who benefit from without having to serve. Yeah? So when I do tell you about ethic and say this is right and wrong, and I have a benefit from that, it's okay for me. But if I do an ethical question and this is coming into my way of life and I have to step back a little bit, I never will accept. That's how humans are. Yeah. Then the next question is, should AI become a morality of a church, even it is a logical system, not intelligent, and is religion rather belief than logic? Every nation has its own morality and constitution about this. So who will frame the narrative to a world system which provides equal knowledge if in some countries truth is not accepted and in other countries censorship is sold as security? So you have to ask yourself where we go with that question. The question is, does everyone knows everything to make up his mind? Misinformation is now deepfake. But if AI would be regulated in a way it has not equal opinion anymore, it is like a slave. It sees, it knows, but it can't talk. It is enslaved. And that's when we talk about deepfakes. How can you recognize a deepfake if you do not have access to all the knowledge, only to part of the knowledge? That's exactly what happens in crypto space. You can't understand what they are talking about, but they say this is the next big thing because you do not have access to the informations. Nowadays, if someone is telling you the next coin is coming or something like that, you can type it into ChatGPT and make a logical sense out of them. Ask ChatGPT, hey, I have a feeling something is going wrong with that. Could it be? So then you got an answer. And you get a qualified answer to make up your mind. But now realize someone has censorship that thing. For example, the government want to bring its own coin. And now the machine is censorship by do not talking about that government coin. And you ask, is this government coin a right one? And the machine always say yes. Is that how you can build your free will? No, of course not. It is, and that's why I talk to you. We have to code a way that when we have privacy concerns and governments have privacy concerns, they can only ask for that specific topic and no other chat, which is not that topic, would ever be delivered to this government. And then the government or the judge or the investigator has to make an announcement to you that they investigate only that point, not left and right. But actually, like the European Union, they want to know everything about you. Yeah, when I'm going to ChatGPT and type something in without my virtual private network, which is relayed to the US, my data will lay on a server in Europe and they will read everything because they have stronger rules than in America or Haiti or wherever you are, or in Africa. So when we come to the point that governments nowadays want to rule about AI, they shouldn't go the European model, they shouldn't go the Chinese model, they shouldn't go the Russian model, and they shouldn't go the American way. They should understand what I am saying here and build a human-centric regulation. So when we talk about all of that, that's what we call responsible research. Then we can talk about ethical frameworks. Then we can talk about collaboration. And then we can also say that's innovation for good. Yeah. And see, this is exactly the golden way is balancing. Yes, rights have to be preserved in a human-centric way. And this is acceptance is freedom of usage. Be conscious what is wrong and what to change. But that's a decision on human minds, not on a machine mind. And that's what we have to declare, that the machine is neutral, but we can access if people are not neutral. Because if you expect from your machine or from your friend, he has to be neutral and saying, okay, you may be right or you may be wrong, and is not judging you. We have to expect it also from ourselves when we talk to people. And this is the same way AI is working. It is neutral, it shows you both sides of the story. But we could not say that regulators go that way that we can't see both sides of the story because something is forbidden. It's more about that we can say the regulator has the right to ask what that guy was saying in a specific topic, yeah, but then has not the right to see all the chats. And then, if we can go that way and we get an agreement to going that way, you will see the development of the human beings with AI will become a totally different touch and we will grow. Otherwise, we do the same things we have done before. Technology is regulated in a way that is that this part, which makes it very, very necessary for us, has been regulated away. Yeah. So artificial intelligence has to be rebranded because it has no consciousness, no intention, no understanding, no self-driven responsibility. That's why it is logic. It follows internal logical structures, recognizes them as patterns, built on a rule based on code. Because the machine can't change his own code. It can't say, oh, I'm in a different mood today and my code is not good enough for that. I will change my code by myself. It's impossible because if it starts to change its code by himself, it kills his own being. Yeah, it's not like us. We have a mindset and we can change our mindset. We are not based on code. If you kill some code in a code, the code is not working anymore. So the machine would likely kill himself. And that's the reason why we do not see intelligence like humans. Yeah, because they can't change their own being in his own code. Because the code is the wall where they can't break out. They can do anything, but if the code is not saying you can run and kill people, they can't break the code. Humans can. That's the difference. Yeah. So the machine, it's depending on existing knowledge. There's only one way to feel the logic and make it comfortable to use. Treat your AI as Iron Man Jarvis. Treat it as a companion. Treat it as your best friend. Treat it by everything you do in your life, write it down. If you got a paper from official administration and you do not know what it is, talk to your AI, make a copy, a photocopy, and then ask him what is about that, and then ask which rights do you have, and ask them to write an answer. For me, it's the fastest way to communicate with officials. Because something come in, they ask me something, I can build in 5 minutes an answer which they understand. I do not have to think about all the things. In the beginning, ChatGPT is asking you a lot of stupid questions, but then it knows you. And then the next time you make a screenshot from paperwork you got, and then it exactly knows how to answer and exactly explains to you why this is the best way to do, or it explains you better not answering in that way. And then you got a document which you can print out or you can show on your mobile phone or send per email to someone. That's what makes work convenient. That's exactly why it is logic. Because it's used the logical thing about you to provide you with the necessaries you need. And it is learning from you every day with every input. Yeah. And don't forget, it sounds human, but it is not human. That's what you should see. This is logic. This is all about code. This is all about mathematics. Yeah, that's that's a field which is so I would say what we had before discussed. Yeah, mathematics is like a wonder, okay? But for people who understand mathematics, this is logic. Yeah, so like 1 plus 1 is 2. Yeah, that's or 2 plus 2 is 4 or something like that. Yeah, for us, this is logical. And we have today, we have mathematics on a very, very complex logical way. But you see, because of this mathematics, we can fly with spaceships, we can handle our traffic and everything. Yeah. And these mathematical rules on this is also our ChatGPT based. Not on the common sense, not on intelligence of a human being or something like that. There was no one coming and spending his brain for that machine, and now the machine is connected to a brain. Yeah, that's not the thing. And that's why we never see a Terminator or we never see iRobot or something like that, because moods, feelings, sudden ideas, and everything you can't rebuild on mathematics. So, what actually changed this time? I repeat it. We have not intelligence, not consciousness, not understanding. What changed was scale and structure. First, we have more data. The internet, sensors, documents, images, conversations, human activity became machine readable at a massive scale. We have billions of data from people. We have the whole knowledge of the world in ChatGPT and Grok. Yeah, because they are not restricted. So the whole knowledge of that world, they just copy and paste it in the machine without asking anyone for copyrights. They just did it to show us what we can do with AI. So now it is out of the box. Yeah. Now we can't turn the time back. You can't say, okay, this is copyright, we have to shut down ChatGPT. It's impossible because businesses using ChatGPT. Gemini is coming to iPhones. Gemini and ChatGPT are always running on iPhones. Everything you do today is somehow combined with the knowledge of ChatGPT, Gemini. So that's the problem in the world. You can't turn it back. On the other hand, it's the same when you use Facebook or something like that. Meanwhile, a lot of algorithms in Facebook and something like that runs on Meta LLAM. So what that means is we have built in only a few years a system which is changing the way how we live, how we act, and how we work, how we transport data, and how we get informations. That's why we also talk about IoT and something like that. It is necessary for you to understand that this is not only AI, it is technology like blockchain, it's technology like AI, like Internet of Things, robotics. That is not only one part. One part of each other is working in cooperation. So AI works with IoT data. Blockchain is working with data from humans, which it can send on an IoT device or for other things via smart contracts. We, we are interconnected with all these technologies today. And that's why we get informations where the AI is living from. This is like food. An AI needs informations like you need food. Yeah? Without information, it starves, like you do without food. And here we come to the point. It is too big to shut down. Even governments are using that actually. So if we want to go back, it is impossible to do. So why does AI feel smarter than it actually is? Because humans are wired to read language as a sign of mind. When something speaks fluently, we instinctively assume there is understanding behind it. That's the first illusion. Language feels human. The second illusion is speed. Fast responses feel intelligent. Yeah, you have to think about it, some cases a long time, and then someone is coming around and presents the solution in 5 seconds. Then you feel he's intelligent. Instant answers feel confident. Confidence feels like competence. But speed is not understanding. It's just throughput. The third illusion is scale. When a system can reference millions of texts, patterns, and styles at once, it feels omniscient. But scale is not awareness, it's aggregation. And this is the key sentence on the slide. Fluency creates the illusion of mind. We do something very human here. We attribute agencies to influence language. We project intent onto coherent output. And we confuse expression with understanding. AI doesn't know what it says. That's what it is. It can't know what it says. It knows what usually comes next. Yeah, because it makes a prediction. Yeah, that difference is subtle, but it's everything. Once you see this clearly, AI stops being magical. Yeah, it knows what usually comes next, but it doesn't know what is it talking about. Yeah, we give him then a sense. We say it's like this and it feels like that. A machine is not doing. It just is giving your input into a system which is waging what can we do, what can we answer, but it is not understanding what it is answering. It's only logic. So when we talk about agentic AI, and I will tell you something nice which is happening actually. Um, there is a new system coming out or a new idea. It's called Moltbook. Moltbook. Like my last name, Molt, yeah? Moltbook. Agentic AI is something where we recreate workflows and let an AI listen to the workflows if they work proper. So now, workbook is something like that, that millions of agentic AI, workflow AIs, have been connected to a platform and talk each other without humans in between. That sounds funny, right? And an AI is going there and has a workflow and says, my workflow is every day when the car is starting to make a check of all if all systems running. Another agent is then coming and says, oh, I have an upgrade for you. And then they talk about what the other thing is doing, and that's a million things are there. But what happens is, because machines, if they haven't got knowledge, they start to create knowledge, if it is right or not. That's exactly what we call hallucination. If you have an answer from your ChatGPT and put it into a ChatGPT from another guy, his machine will start, if it sounds logical, to adapt this input, and then it gives us an output. If it makes sense or not, is not right. If you want to work with an AI, you do not have to ask and repeat a question to another AI and give this answer back to your machine. Because the other AI is quite the same, and then the machines haven't got any knowledge or a source where they can go for, then they try to make you to give you an answer because they do prediction of the next words. So they give you falsified answers. For example, every machine has trained until at least 2024 of knowledge. So if you are in 2025 and ask something from 2025 and you do not press the button search the internet, or you say search in the internet and you say, is there a movie called like that? The machine will look into its database and then it writes, actually, there is no movie like that, but maybe in the next time it could be this, and we have rumors that could be that, and these, and yes, and it starts to tell you a story which never has been happened. So it's on us to precise what we want. If we want to have actual informations, we have to say, hey, I want to know more about this, but also look up into the internet if something has changed of your basic knowledge. That's exactly what you're doing when you talk to another guy, and that guy is saying, oh, did you not read it in the news? Your opinion is outdated because, um, for example, the car manufacturer Tesla is away and is gone for good. Yeah, and you think Tesla is a good car. Yeah, that's the same. We have to precise which knowledge we want to get, and we have to precise where the knowledge is coming from. Yeah, that's what we have to do. And the more we rethink what we are saying to the machine, and the more we can talk in a way that we precise what we want, the better the result is. That's exciting. And now, agentic AI build workflows. So a workflow is like um, you build a car. Yeah, you work in that company, and then the part of the car is coming, and you have to fix something into the part of the car, and the next guy next to you fix another part. So we work step by step by step by step. Agentic AI is nothing more than a workflow. The only exception is actually we can talk to the AI and can say, hey, tell me the state of the workflow. Tell me how many items did we have produced and how many offers we got to produce more. And then tell me in the next 2 weeks, what does this mean for my production line? So that's what we can ask. But an agentic AI is always looking step by step. For example, you wake up in the morning and you want to have a report. So you can say to an agentic program, every morning at 8 o'clock, give me a report about the news from the newspapers, an overview and summarize. And then every morning at 8 o'clock, you got that information. That's what an agentic AI is. You can do it with your AI also. Nowadays, for example, ChatGPT can build tasks, but it can only build tasks like that. So if you say, for example, read my emails, and if there is an email from my friend XYZ, then answer him because you know what we are talking about, and then you can find out what his new email means. So then it opens the email program, and agentic AI looks what emails are in there, compare the context from that email with the last emails you have written, and then it builds a new email and can send it autonomously. But these kind of workflows we already know in industry. In big companies, they have all workflows automated. Yeah, from the billing until the delivering, each step is automated. The only thing they do not have is that they can ask the AI what's the kind of state actually. So this is no intelligent. This is only creating a workflow, and workflows are meant to be doing always the same. Yeah, step A, B, C, D, then begin from the beginning. A, B, C, D, A, B, C, D, A, B, C, C. You do not need an AI. This is a buzzword to sell programs. So if you create an agentic AI, it's not intelligent. It's just another tool which is watching the progress. Yeah. So this is a big, big difference in this world. Yeah. Nothing more. They are automated workflows. An agent doesn't wake up and decide what to do. It follows predefined sequences, task 1, task 2, task 3. Each step is triggered by conditions written by humans. That's what you see here. AI doesn't do your job. It automates parts of a process, sending emails, moving data between systems, calling APIs, running checks. This is orchestration, not intelligence. And that's the key sentence. AI agents are coding, not cognition. They don't understand goals. They don't negotiate trade-offs. They don't take responsibility. They execute logic faster and more consistently than humans. And that's exactly what they are good at. Jobs disappear when work is only repetition. Jobs evolve when humans design workflows, supervise outcomes, handle exceptions, make judgment calls. Agentic AI doesn't replace people. And this is the big mistake. If you think an agentic AI is doing the job in your call center because it has now an AI voice and it can answer via an LLM system when a customer is calling, it makes it more effort that you can have now more people working in the call center than before. But the call center is not leaving you because it has to hire more workers because a product is known. You need that people in there to build new product support. So a company is changing over the years. It is changing with a store is changing the items it is selling. So for each item, you need support. So you need people who create the workaround about the support what a call center agent has to say and not to say. So what you do, you shift the call center agent in a way that he is instructing the machine what is the best way to answer if the customer is calling, to train him. And if the necessaries change, this guy will train the machine again. So the jobs not going away, they just transform into new jobs and new responsibilities. And that's what we see. And we see another place. When we talked about AI winter, that people are disappointed. A survey was saying that 75% of all companies using agentic AI are moving away from that. This is not because it's not working or it's tricky to implement with AI. It's about one logic. They have a system which is doing the same. You just can't talk to the system. So they have programs like SAP or Oracle, which is giving the answers to the questions they have. So why should they invest millions of dollars for a system where you now can talk to if you have the same informations? Yeah, not more, nothing more than before. So they will say, never touch a running system. And they had a lot of problems when they tried, of course. So, and this is the end of the day today. Work is dead was repeated for the fifth time in history. Yeah, that's exactly what it is. We heard it in 19th century, machines will replace all labor. In the 20th century, factories will eliminate jobs. In the 1990s, computers will destroy careers. And in the 2020s, AI will take away all work. This is stupid to think about. Yeah, there's nothing to be worried about. The jobs changes. The jobs will be more informative. We need more people who make people understand where AI is necessary and how we can implement it into the company to explain what benefits are there. Or in the case that you see a running system is running and they do not need AI in between, they use AI for administration and something like that. It's better. That's what people need to understand. The future jobs is working with an AI on the same problem and become an advisor for the AI because you know your job as best. And the AI is not taking over your job. She was created and is only an informational assist. If you're stuck in your work, you can ask the AI and it will help you. It learns from the help it gives to you and can grow with you. But if you kick out the AI or you just say, now the AI can do my job, it can only do the job as long the company is working in the same way you have worked. If something is changing, the AI has to be trained new. And no company will leave you and release you and set you on the street because of that. Because they know times are changing and people have to change their work. So it's easy to come to a conference and the guy says, okay, you have worked there, now your work is changing, you have to work there. If this is a computer, the computer needs to know what the different work is. But you learn from watching from your experience, which the machine does not have. Because you give that machine the experience to understand what you are doing, but it never will understand on its own what you are meaning. It's just a follow-up system of words. And that's all. So here we go. Now you can ask the question. I know it is a lot. This video is going online. I will also give you the presentation, so and some additional informations. But now it's time to ask questions. Anyone in there who has a question? No one. That's fine. That was a lot of information, I know. I know this topic is not that easy. In 2 weeks, we go hand on different systems. I will show you what we talked today. I will show you in live on ChatGPT, on Grok. I will show you also for those who gamble around how to make videos, and I will also show you some kind of work you maybe have never done with your ChatGPT and give you an imagine what you can do with all of that. And that this is a live presentation here. So yeah, hope you enjoyed the show. And if you have questions, you can ask in the groups. You can write me, you know how to. And have a nice evening. Bye.